I just want us to remember, right, that when we are given any diagrams, we normally have a sample set. And I need to erase all of this nonsense here. All of this extra stuff needs to go. I'm going to delete all of that. Okay, just a reminder before we continue, right, that normally we are given a sample set, right? We're given a sample set. Let's say maybe all the numbers from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then normally we'll get subsets of our sample set, or we can call it the universal set, whatever it is we call it, right? The subset, let's say maybe A is all the multiples of 3. That would be 3, 6, and 9 here. And then you'll find that for our subset B, we would have all the even numbers. So 2, 4, 6, 8, 10. And then you'll find that because these two will overlap, you'll find that they'll have 6 in common. So when we put our Venn diagram together, we will have 2 circles for our 2 subsets, and they will overlap because they both have 6 in them. Subset A has 3 and 9 as well. Subset B has 2, 4, 8, and 10 as well. And then my bigger set on the outside, which is my sample set A, my sample set S would also have 1, and 5 is missing, and 7 is missing. Okay, and that's how we can put all of that together. All right, thumbs up. Are we all okay with the idea of what ma'am has just drawn on the screen? I think we should all be used to it at this point. Yes, lovely. Okay, so let's get into today's work, because today we're going to be doing something a little bit more extensive to this. All right, we're going to start with something simple like this. Okay, it says here is a Venn diagram. It says, write down the numbers that are in set D. Okay, what numbers are in the set D, guys?
6.
6. Yes, Unati.
Or in set D, it's 659.
That's it. Well done, Unati. Absolutely. Guys, remember, the whole of D would include, we must draw a thing around the whole circle. So all the numbers in here, that is part of set D. Okay, now the next one here says C union with D. So union with D just means C or and D. Oh, I'm lying. It actually means or. Okay, C or D. So if I had to choose any of these numbers, I want any of them that are in either set C or D. Which numbers would fall in set D or in set C or D? We're all in agreement. 6, 5, and 9 would be everything in set D, right? So I would have 6, 5, 9. What am I missing? What else is there to include?
1 and 4.
1 and 4, that's it. Correct, my darling. Yes, 1 and 4, because 1 and 4 also makes up part of the circle. 1 and 4. Now, the C with a little apostrophe means not C. And remember, we spoke about not, yes, but we talked about it in probability. So when they say not C, all we're going to do is we're going to circle C, and whatever is not in C is the answer that we're looking for. So there, I've circled everything in C. What is not in C, grade 10s?
6.
6 and? Yes. Yes, Unachi.
7 and 11.
That's it. And 7 and 11. We mustn't forget the ones that sit on the outside as well. Oh, Unachi on fire today. Well done. Okay. Lovely. Good stuff, guys. All right. No worries, Amanda. You got this. Yes. Good. 6, 7, and 11. All right. Okay. Let's go into some extra stuff today. Right. Today we're going to be talking about how to figure out what happens when we have an overlap and how to find the overlap in between each of these. All right, let's read the question over here. It says, There are 80 students. There are 80 students in year 11, right? 9 students study French and German. Where does this French and German, where do I put those 9 students? Who can tell me? Where do those 9 students go?
In between that.
That's it.
Yes.
Absolutely. What do we call that part where they overlap? It's an inter something. Intersection. I heard that. I don't know who said that, but yes, correct. It's an intersection. Good. So the 9 students will go in the middle here. Okay, in the intersection. Are we all okay with that? Lovely. Okay, cool stuff. Yes, Kiabetu, I think Kiabetu meant yes. All right. So it says now 35 students study only French. So in the French side, where F is, we're going to put 35 students. And now it says 2 students do not study French or German. Where do I put these 2 students that don't study French or German?
Inside the box, but outside the circles.
That's it. Oh, lovely. Who is this lovely person who's giving me all the right answers all the time?
We can know.
Hello, Wikanyo. Thank you so much, my darling. Okay, so 2 students go out here. Now we've got to complete the Venn diagram. What's missing? What is missing? The German students are missing, right? The students who take German only. So if we had to calculate for the students who take German only, we know that there are exactly 80 students. The only way we're going to be able to find this is if we name it X and we just do a very, very simple calculation. We can go X plus 2 plus 9 plus 35. All of this must equal the number of students in year 11, which is 80. All right, find me an answer for X, please, guys. X is equal to what?
34.
34. Lovely. That's the correct answer. X is equal to 34. So sometimes they will give us some information, but not all the information. Now, I want us to be very careful, grade 10s. The way in which this information is written is very important. So we're going to look out for words like and. We need to make sure we're understanding and. And also, if they add in an only, the word only is also very important. And the word do not, or the words do not, are very, very important when we go about answering the following questions. So I want you guys to stick with me as we look at a different example. Okay, let's look at the question that we've got here. It says, at a wedding, the guests may have ice cream or custard with their dessert. The Venn diagram shows information about the choices the guests made. All right, so we can see here that 51 people took ice cream only. Why do I say ice cream only? Who can tell me why I don't just say ice cream? Why do I say ice cream only? Who's got an idea? I'll give you guys a hint. It has something to do with these nine people. Who thinks they've got an idea?
Because 9 means that they both share. I'm just guessing. 9 means that they share both 9 and 51. But if it's only 51, it just consists of only the one circle, the 51 as.
Okay, you're making sense, but I think you're saying it in like a roundabout way. Okay. All right, I'm going to explain something. I'm going to explain something, but thank you for giving that explanation. I think you're spot on. I think just the way that we've articulated is a little different. All right, so if I said to you guys, how many guests had ice cream? How many guests had ice cream? Pop your answers in the chat. Okay, Amanda says 51. Sally says 60. What does everyone else say? I'm getting 2 different answers. I need to see if we can get a consensus here. Okay, abulele 60, palesa 60. Fortunate 60. All right. So here's the problem with the way that these kinds of questions are asked, right? When they say, how many people took ice cream? They are not in this case considering that there are other people who had ice cream and custard, right? So imagine if you've had both ice cream and custard and somebody comes and asks you, did you have the ice cream? You would say, oh, yes, the ice cream was lovely. It was so great. And then they would ask you, did you have the custard? And you'd say, yes, of course I had the custard. I did. It was lovely. It was so nice and creamy and vanilla-y. I loved it. Right. The issue comes in when we say, did you have the ice cream and the custard? And you're like, no, I only had ice cream. So do we see the difference between ice cream only and just ice cream? Thumbs up. Am I making sense? Because there's a chance that I've had both desserts. I could have ice cream and custard. And if anybody came up to me and asked me, did you have the custard? I would say, yes, I did. And if they say, did you have the ice cream? I'd say, yes, I did. But I'm in the in-between. Now, if I'm ice cream only, if somebody came to me and said, did you have the custard? I'd be like, no, I only had the ice cream. All right. So when they ask us, how many people had ice cream? We must also count this person in the middle who would answer yes for both. Okay, so if I say to you guys, how many people had custard only? How many students had, or how many guests had
43.
43, custard only. So 60 or 51 ma'am for ice cream. Amanda, there's a difference. If I said ice cream, you need to count everyone in the ice cream circle, everyone. But if I said ice cream only, I can't count this person because this person has had both ice cream and custard. So now I ask you guys, how many people had custard only? Custard only. It can't be 47. Sally, you're onto something. Yes, 100%. Amanda as well. That's it, Kiabetswe. The answer would be 34. Because if I count the 9 in the middle, they didn't only have custard. They had custard and they had ice cream. Okay. Am I making sense? Guys, if I need to explain again, please put a thumbs down. I'm so happy to explain again. All right. Okay. So let's say, for instance, they're asking us here, right? How many people had custard? I need to circle the whole, oh, sorry, how many people had custard? I need to circle this whole thing. Just like that. I need to circle that whole thing. Through and through. In fact, let me do it in pink. I have an idea. Okay. Right. Okay. So these are the people who had custard. Everybody in the whole circle. These are the people who had custard. The people who had ice cream would be those people. All right. So if I ask you, how many people had both ice cream and custard? How many people had ice cream and custard?
9.
9, right? We can see it in the middle, right? 9 people had ice cream and custard. What does this tell us? These people are still part of the ice cream circle. What does this tell us about these 51 people? That they had ice cream, but they didn't have custard. Is that making sense? Yes? They had ice cream, but they did not have custard, which means this 51 represents ice cream only. Okay. Am I making sense? Right? Now, think about what I've just said. How many people had custard only? How many people had
34.
custard only? That's it. 34 people had custard. Only, because we can't count the people in the middle. These people had custard and ice cream. So how many people had custard only? 44. All right. Okay, I'm going to ask for one more thumbs up. Are we all okay with this idea? I'm glad. All right, lovely, 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 lovely. Let me just quickly get this done here. Sorry, I just want to answer this one message. All right. Okay, cool stuff. Now, let's look at the questions that they've asked us over here. They say, how many guests had custard? Not custard only. How many guests had custard? My question now is, do we count the people in the middle?
I think so.
Why do we say so? Because did they actually have custard?
Yes.
Yes, it's just that they also had ice cream. So how many people had custard? 43. We need to take the 34 plus the 9. So 43 guests had custard. Okay, let's look at the next one. How many guests had ice cream and custard? So how many people had both?
9.
9, right? The only people who had both are the people in the middle, right? So 9 people had ice cream and custard. Okay, now it says, how many guests went to the wedding? How are we going to figure that out? We're just going
We're going
to
to add all the numbers.
That's it. Let's add everyone together and see how many people went to.
107.
107.
That's it. 107 guests. All right. Okay, let's look at this next one over here. Okay, so this one is a little bit more tricky, so we need to have our wits about us. Okay, let's think about this. It says, everyone in a class who took the PE test passed at least one section. Oh, sorry, I'm reading from the wrong part. Okay, I need to start from the very beginning. A PE test has 2 sections, theory and practical. Okay, it says everyone in a class who took the PE test passed at least one section. So everybody at least passed one. They either passed theory or practical, or what's the other option? They've either passed the theory or they've passed the practical, or what? What's my third option?
Both.
That's it, Balissa. Mwah. Excellent, good. They've either passed theory or practical or both. Okay, so now the question says 62% passes the theory section and 83% passed the practical section. We're going to have a problem. This thing is in percentage, right? What's the highest percentage of people we could possibly count? What's the highest number in percentage that we could possibly get? I know we're thinking, yes, that's correct. We can possibly think of bigger numbers, Buikanyo, but what I'm getting at is how many people are in the class in terms of percentage. We can only get 100% of the people in the class. Is that making sense, Buikanyo? I hope I haven't lost you. Yes? If we're counting up everybody in a class, there needs to be exactly 100% of the class, right? Now, we can tell from this that we're going to have 2 circles, right? One for the theory and one for the practical. So I'm going to put 2 circles in here. There's one circle, there's the next circle. Okay, and I know they will overlap because we already know that they will either be the theory part of this, the practical part of this, or they'll be both. Now, I'm going to run into a problem, okay? In that there are 62% of people who passed the theory and 83% of the people who passed the practical. If I take 62% and I add 83%, How much do I get?
145.
I get 145%, but my classroom is only 100% of people. What does that tell me about the intersection over here? How many people actually go in here? What percentage of the people would go in the middle?
45.
That's it. Good, because the whole thing needs to be 100%. So in the middle here, we need to have that 45% of people who's extra because they've passed both. Thumbs up. Is everybody understanding how we got there? Yes? Excellent stuff. Cool stuff. All right. Now I'm still going to have a problem, guys. I'm still going to have a problem that 62% of them passed the theory, 62%. And 83% of them passed practical. If I add all of this up, that gives me way more than I needed to. But remember, guys, 62% passed the theory. So the whole of the circle must be 62%. 45% of that has already been accounted for. So how do we find the people who passed theory only? How do we figure that part out? Okay, I'll say that again. I know that the 62% of people passed the theory part, but do you see how in the theory circle, the 45% has already been counted? It's already been counted in this section. So how do I figure out how much goes in the theory only part? That's it. Correct, Leto. Well done. I don't know if I should call you Leto or Amani, but you definitely have the correct answer. Right. We'd need to take 62 minus 45 to figure out how many people passed theory only. Am I making sense? Thumbs up, thumbs down. Is it Leto? All right. No worries. Okay. All right. So we need to take 62 minus 45 to get the rest of it. Okay, somebody find me an answer. 62 minus 45?
17.
17.
17%. Lovely, good. And then obviously we're going to have to do the same thing on the practical side. We know that the whole of practical needs to be 83%. But if we draw a circle around practicals, you'll see that the 45% in the middle has already been accounted for. Right. So in order for us to find the kids who passed practical only, we would have to take 83 minus 45. How much does that give us?
38.
38.
How much?
38.
38. There we go. Thank you. 38%. Lovely. And now, when we add all of this together, it should then give us exactly 100%. Check for me. 45 plus 38 plus 17. Does that indeed give us 30? Does that give us 100%? That's it. Lovely. Okay, cool stuff. All right, now it says a student is selected at random. Work out the probability. Now we need probability that this person passed theory given that they passed the practical. What does this actually mean when they say they passed the theory given that they passed the practical? It means they need to have passed what are we thinking? Yes, Amandla, absolutely. They need to have passed both. So what is the probability that they would have passed both? 45%, because that's the percentage of the class that has passed the test. So we can say 45 over 100. And if we reduce this I think we can divide by 5 on the top and on the bottom, 9/20. That would be the answer. Okay. All right, peeps, how are we feeling? Are we okay? Thumbs up. Okay, cool. Because I'm going to complicate life just a little bit more, as you know, as you well know. Teacher Coco always does. All right, okay. Let's look at the words and, or, and not. Okay, because they're very, very important. They're going to keep coming up again and again and again. All right, what we're going to be doing today is we're going to be learning the symbols. We're going to be learning these 3 symbols, and I need us to remember them. Okay, that symbol like that looks like an upside down U. This symbol that looks like a right side up U, and this little apostrophe over here. Okay, so we can look at the idea of if we have 2 circles inside our Venn diagram, the and part, when we say and, we need to make sure that the part that we're looking at is contained within both of our circles. We call this symbol an intersection. Okay. So whenever we see the word and, or we see the word intersection, we are looking for the part where both of these are included in there. Okay. All right. If we look at the next one is an upside down U, and the U literally stands for union. Union means everything in A and everything in B. So both of these things together constitute a union. So if we see the word or, and we know it's or because or gives us more options, right? Or means more options, which means everything in A and B together. And that's what we call a union. Okay, so if we see or, we see union. And now, then comes the apostrophe. The apostrophe means not. It means not. And remember we talked about not? Not is basically 1 minus everything that is. So if they say not A, what we need to do is go and highlight the whole of A, and everything that A does not touch is the thing that we want. All right, and we can see this on a Venn diagram by either looking for the word not, or if they use the word the complement. And the complement basically just means the opposite. It means the opposite of the thing that we want. All right. Okay, thumbs up. Are we all okay? Okay, take this down. If you need to take a screenshot, please do, because we're about to use these in the next section that we're about to embark on. But there's certain things about them that we need to know, and certain ways in which we need to use them in order to use them effectively. All right, let's look at this example over here. So it gives us a universal set. Now this universal set is the same thing as our sample set S. We can call this S if we would want. All right, now I want us to create a Venn diagram using what we've been given over here. Now, S is our main set, A and B are subsets. Okay, so I want you guys to draw a Venn diagram. When you're ready, pop an emoji either in the chat or on the screen for me, please. How are we doing, peeps? Are we ready? I'm going to get started on mine and see if yours looks like mine. I'm going to draw my big circle for our sample size, our sample set. S, and then I'm going to put 2 circles. 1, 2. Move that in a little bit. And then there's definitely going to be an overlap. Right? This is going to be sample set A. This is going to be B. Right. Now, first thing I'm going to go do is I'm going to go look for the intersection. I'm going to go look at what's in both A and B because that's what goes in the middle. So I can see C, C, D, and D. So in the very middle here, I need to have C, I need to have D. In set A, I need to have E, and in set B, I need to have A. And the only thing that's missing from our sample set or universal set U is not C, B. B is missing, so B must go in the rectangle. Thumbs up. Does yours look like mine? Everybody else, how did we do? Did we do okay? Yes. Okay, lovely. Okay, now let's talk about what they want from us in the questions over here. All right, so first question says here, A apostrophe. What does the apostrophe mean again? Do we remember? The apostrophe means not. Good. It means not. So they want everything that is not in A. So what we're going to do is we're going to go put a circle around A, and we're just going to look at everything that is not in A. So not A is going to be a set with just A and B in it. All right. Okay. Now the next one says not B. Not B. There's the not. Right. So we're going to go put a circle around B, and anything that is not in B, that is our set. So not B is going to be E, B, and E. Those are the 2 things that are not in in subset B. Right. Then the next one says A, U, B. What does that mean? A, U, B. What does the U mean? It means union, absolutely. What does the union tell us? It tells us everything in A or B. It should be more. So we're putting all of them together. So A, everything in A or anything in B. So both of them together is going to be everything except B, right? So we'll have A, we'll have C, we'll have D, and we'll have E. All right, and that's what we will get there. Okay, then the next one is a little bit tricky, right? Because it says anything not in A or anything not in B, right? So what is not in A or not in B? It's just B. Well done, Kiabetsu. That's it. Just B all its own. Lovely. Good stuff. So this is just equal to a set with just B in it. Okay. All right. Let's look at number 5. Number 5 says A upside down U. What does the upside down U mean? What does that represent?
Intersection.
That's it, the intersection. So we're looking at A and B. So in order for us to use that, it needs to be in both A and in B. That's a much smaller space. So it's going to be just that part there. So A and B is going to be C and D. Okay, now it says everything that is not in A and not in B. So what is not in A and not in B? Not in A and not in B. What do we have that is not in A and not in B? Just B, correct. Okay, so now I'm writing in highlighter. So equals B. Actually, guys, you know what? I think I need to come back to number 4. I think I may have written that one down incorrectly, but I'll explain in just a bit why I think so. Okay, just give me a second while I don't erase my whole life here. Okay, but we'll come back to that. All right, I'll come back to number 4 just now. Okay, the next one says not A and B. So everything that is not in A and in B. Okay, so let's think about what is not A. Okay, so this is A. This is A. We want everything not in A and B. So what do we leave then in this case? A, we're missing something. That's it. Correct. And B, good. A and B as well, right? Oh, guys, I'm lying. You guys are correct. It's just A because B is not in. Oh, no. That's the not A part. Yes. So B does count because not A includes this B on the outside. So you guys are spot on, A and B. All right. Then the next one says everything in A and not B. Okay, so we're going to go first for the not B. So this is everything in B. Right. So everything in A and not B would leave us with B and E. That's it. Correct. Well done. Fortunate. Well done, Amantla. Okay. Right. That would leave us with B and E. Okay. Now it says not A or B. So everything that is not in A or anything that is in B, right? So let's go ahead and see. So everything that is not A, this is A or B. What does that leave us with? What do we have there? Yes, we've got A. Okay, and over here it says A or not in B. A or not in B would be just not B, Amanda, in this case. Just E, that's it, fortunate. E. All right, are we okay with this exercise, everyone? Is everybody okay with the yes and the no, the not, the union, the intersection? All right, it's your turn. It's 100% your turn. Oh, Desmarie's having the time of her life with those with those emojis there. All right, here is your next challenge. I'm going to be quiet. I'm going to give you guys a few minutes. Here's a Venn diagram. They've already given you numbers. I want you guys to write down what we think here. We've just done it. This time it's with symbols and not with me telling you what the thing is not. Okay, fill those 3 in. Pop your favorite emoji in the chat or on the screen when you're ready. All right. It's looking like many of us are done. Shall we have a look at the answers here? All right. So it says here, here's a Venn diagram. Write down the numbers that are in set D. Now, the whole of set D is just that. D, which is 5, 9, and 6. So our answer here should be 5, 6, and 9. Now, the next one says C union D, which means everything in C or everything in D, or means more. So we should have a lot more numbers to go into those two sets. So we'd have 1, 4, 5, 6, and 9. Those are the answers we'd get. All right, the next one says C apostrophe, which means not C. So we're going to put a circle around everything that is in C. Anything that does not touch C is what we've got. So we've got 6, we've got 7, and we've got 11. All right, how did we do? Did we do okay? Well done. Whoop, whoop. Good stuff. All right, here is your next one. So make sure there is another question. Okay, let me just make this a little bit smaller so we can see everything in one go. All right, here we go, peeps. I'm going to give you guys another 3 minutes. Go ahead and try and answer this one. Well done, Amanda. All right. All right, it looks like enough of us are done. Let's have a look at the answers. All right, so we are given this Venn diagram over here. It says, write down the numbers that are in set A intersection B. Now this is AND, which means they must be both in A and in B, which means just those two. So 4 and 9. All right, the next one says A union B. Union means more. It means or means more. So everything in there and in there. So we get 4, 5, 9, 16, 25, and 36. All right, and the last one, it says A apostrophe, which means not, anything that is not in A. So we will draw a circle around A, and anything that is not in A is what we will pick. So 5, 17, and 40. Did we win? Yes, Desmarie. I'm seeing your hand is up, my darling. What's up?
Ma'am, I wanted to ask, does it always have to be in a certain order from smallest to biggest?
No, that's just ma'am's OCD kicking in. Don't stress. As long as you've got all the right numbers there. Okay.
Okay, thank you, ma'am.
Right, my darling. No, it's not necessary for it to be in order. Don't stress at all. Okay. All right. I'm glad we're having fun with this exercise. Can I step it up a notch? Are we allowed to? Yes. Do I have permission to no, Sia's like, no, ma'am. No, 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 no. There's always a for now. You know this, Desmarie. You know this for a fact. You know this for a fact. So I don't see why we must be that shocked. Okay. I don't think we should be that shocked. You must always know that there's a something else coming down the line. All right. Shall we look at something a little bit more challenging? Okay. Here we go. All right, let's read the question very carefully. We're going to create a Venn diagram off of this information. Okay. Right. It says, in a group of 22 people, 5 like neither tea nor coffee. Right. So how many categories do we actually have here? We've got 2. That's good, Desmarie. That's good. Okay. We've got 2 categories, right? We're either going to have tea or we're going to have coffee. Right. Now it says, those who like only tea number 1 more than those who like only coffee. So now they're not being very specific. Okay, they're not being very specific. They say the number of people who like both drinks is twice the number of those who like coffee. Let's put this into a Venn diagram and let's see. Okay. So I know I'm going to have a Venn diagram, right? And I know that my sample size is 22 people. 22. Then I'm going to have 2 circles. 1, 2. Where's the other one now? Come now. There we go. 2. All right. Okay. Now we're going to have a bit of a problem in that we don't have any numbers. Okay. But here's what they tell us. They say those who like only tea number 1 more than those who like only coffee. So I'm going to make this tea and I'm going to make this coffee. Right. Now, I don't know how many people like coffee. So I'm going to name that X. Okay. Who can tell me, why have I not put the X and joined it in there? Why have I not put it as part of that pot? Why am I putting it in this pot over here? What does the sum say? It says those who like what? Yes, Desmarie, I think it is. I think it is. Okay, let's read that sum again. It says those who like only coffee. So can I include the intersection? Good, Amanda, that's it. We can't include the intersection because that's the part, that part would be coffee and tea, right? So now they're saying those who like tea number 1 more than those who like only coffee. So what am I going to put in the only tea section? If only coffee is X, what is only tea going to be? If the only teas have to be 1 more than only coffee, what would I put there? Okay, let me do this. Thumbs up or thumbs down who's lost, thumbs up who's still with me. If you're still with me, give me a thumbs up. Thumbs down if you want me to explain again. Okay, many people are lost. Okay, that's fine. All right, let's look at it this way. We know that there are 22 people, right? We know that there are 22 people. Okay, if we look at the information that we've been given, they're saying here, those who like only tea. Which section over here is only tea? Are we in agreement? Just give me a thumbs up or a thumbs down. Are we in agreement that it's just this part? Yes? Are we all good? Lovely. Okay. So now the question says, Those who like only T, number one more. What does one more in maths mean? What does one more in mathematics mean? Plus one. Yes, correct. It means plus one. Right. So they're saying that the only T people are one more than those who like only coffee. Now, are we all in agreement that only coffee is this part? The part that I've highlighted in pink. Thumbs up. Are we all in agreement that only coffee is just that part? Okay, great. So I don't know. They don't actually tell us how many people like only coffee. So I'm going to name that part X. Thumbs up. Is everybody understanding why ma'am has named it X? Yes? Because I don't know how many people there actually are in that section, right? But now they're telling me that the T section is one more than only coffee. I know what the only T part or only coffee is. So what would only T then be? How would we write that? If only T is one more than only coffee. That's it, Sally. Absolutely. That means T needs to equal X plus 1. Thumbs up. Everybody understanding where we're coming from? Excellent. Fortunately, you still look a little bit lost. Okay. Still a little bit iffy, which is okay. All right. I want you guys to take a screenshot of this question that we're working on now. This is the question that we're going to start with on Wednesday. Okay, because this is part of your quiz. All right. So please take a screenshot. We're going to stop the lesson here for today, and then we'll continue from here on out in the next lesson. All right. Okay.